Oh, sorry. If I stand up, I'm a little further away from the microphone than I'd like to be, but can everyone hear me if I... Can you hear me at the back? Excellent, okay. Because I tend to move around a little, so I don't like sitting down. Anyway, buongiorno. Now, I hope you'll forgive me that I'm not going to even attempt to speak any more Italiano, because if I do, I'm sure I would be arrested for crimes against your beautiful language. So, unfortunately, the rest of the presentation will be in English. My name's Mark Allison. I work for a company called Blinkbox, who are owned by Tesco, who are a big UK supermarket. I'm currently working on an app which we're due to launch next month, which is an ebook reader shop. We're taking on Kindle, basically. So, as I say, we launch in the UK next month. I also write a blog called Styling Android. I've just actually literally been down struggling with the Wi-Fi trying to get this week's post out. So this week's post has just gone live. I'm also on Twitter. Now, my Twitter address is highlighted. I will be live tweeting throughout the presentation. So there will be links to blog articles I've written in the past and also other relevant information. So if you want to follow the Twitter stream, please do so. That's assuming that the Wi-Fi holds up. So I make no promises for that. But yeah, there should be some interesting information going on the Twitter stream. So probably the first question is, what is graphical magic? I'm assuming that we're mainly developers here. We're all friends. There's no sort of managers or graphic designers in here. So I'm going to use a very, very technical term. I'm not sure if this will translate into Italian. But I guess I should be a little more explicit than that. We're going to do some Photoshop-like image manipulations. We're going to do them in code. We're going to do them in Java. We're going to do things like flattening and merging stuff. So we're going to flatten drawballs into each other. We're also going to perform some filters and some special effects. So we're going to create some cool-looking things. And it's actually great fun as well. So I hope, if nothing else, you just go away and have a look at some of the APIs we're going to cover. And look at them, have a play with them, have fun with them, get inspired by them. I will make one very, very big disclaimer at this point. The code samples you're about to see are crap. They really are rubbish. They are not production ready. So if you take these code snippets, put them in an app and it crashes after you launch and you get fired, don't blame me. They are kept deliberately short to keep them understandable. There's some core concepts in here that are important. What I want to do is excite you about the APIs, excite you about some of the really techniques with very little code that we can do. Go away, learn them, play with them, then productionize them, then don't get fired, and then I'll be happy. So why do we need to do this kind of stuff? I just mentioned the word Photoshop. So if we've got graphic designers who can do all this Photoshop stuff, then why do we as developers need to do it? Well, we may have images that get downloaded at runtime. So it's not stuff that gets baked into our app that our graphic designer tweaks. We stick in our resources folder and it loads. We may have images downloaded at runtime that they maybe can't tweak. But, I hear you cry, what if we're in control of these images? So we're downloading them from our own server. We may also have images that are coming from sources outside our control. For example, if we're consuming an RSS feed where someone else is in control of the image, our graphic designers can't do the necessary tweaks we want to make it look good in our app. So we can use some of these type of techniques to do some cool stuff when we're not in control of the image. We may also have some of the effects parameters are dependent on other elements within our app. For example, most of the examples we're going to see is a text view sitting on top of an image, and we'll do some cool stuff with it. If that text is dynamic, that we're loading from a different source, or if the text itself we need to internationalize, the actual bounds of that text will vary at runtime. So if we've got variable text bounds, then the effects that we're doing will change. So if we have a pre-baked image that expects the text at a specific size, it ain't going to work. So we can do stuff on the fly based on the actual text we have available. Hopefully that will become sort of obvious as we continue. The other thing is, this is a great big buzzword at the moment, reduced GPU overdraw. Personally, I think too much is made of GPU overdraw. If you have a list view and you're not recycling your views, that is going to cause you a much bigger problem than any level of GPU overdraw. The sorts of things that GPU overdraw highlight is that you've got inefficient layouts. So what you should do is go in, flatten your layouts, make them really, really efficient, and you'll reduce that anyway. But if you've done all of that and you're still trying to get these last couple of frames per second, there may be some little tricks you can do here. And that's where we'll start. We'll start with a very, very simple trick for how you can reduce GPU overdraw. So here's an image. We have some text overlaying it, and we have a background drawable on the text. So for those of you that don't fully understand what GPU overdraw is, it is when you do an on-draw pass, how many times each pixel gets drawn by the GPU. So in this case, if we ignore the slide background and everything like that, just take into account the image and the text view, we have a worst case of some of those pixels of a GPU overdraw of 3. So some of those pixels will be drawn 3 times by the GPU in a draw pass. The reason for that is we have the background image, then we have a semi-transparent layer, so anything inside that green semi-transparency is going to get drawn a second time, and then we have the text being drawn on top. So more accurately, it's actually some of the anti-aliasing around the text is the worst bits, but ignore that for now. Keeping the example simple, GPU overdraw of 3. In real terms, that's not going to cause us too many problems, but if you've got a much more complex layout than that, it could do. So let's break this down. So there's something that usually pleases a room full of developers. Here's some code. What we have is a very simple layout. Hopefully, I don't need to explain that to you guys. I'm assuming you understand basic layouts. We have a relative layout with an image view with a picture of the beautiful Broadstairs, a lovely English seaside town, with a text view sat on top with a background color, semi-transparent. So here's some code to actually flatten that layout somewhat. Let's separate our 2 graphic components, and they get passed into this, this function as parameters. So we have our image view and we have a text view. It could be any kind of view, so I've just abstracted it to a view in this example, but it's a text view. So the first thing we want to do is make a duplicate of our text view, of our image view. The reason for this is because of where we would call it in the draw lifecycle. I'm hoping that most of you know that layout pass is heavy because you're doing lots of calculation, you're measuring objects, you're working out where they're going to be positioned. You do a layout pass once, and then you can call on draw much more frequently. If the layout's not actually changing, you can call on draw. And that's why you shouldn't do any heavy lifting in your on draw method. You shouldn't be doing object allocations and that kind of stuff. What we would do here is this needs to be called between the two. So a good way of doing this is using a pre-draw listener. So what you do is you override your on layout changed, or your on layout, you detect a layout change, and you register an on pre-draw listener. That on pre-draw listener gets called just before on draw. Now when that on draw listener is called, the first thing you do is cancel it. So it only gets called once, just before the first frame is drawn. So even if you're doing an animation or something, it will just get called the once between the layout and the draw. So when this is called, you know the positions of everything, you know where they're all positioned, you know their sizes. So we can then do some flattening work. So effectively, we're making our on layout a little heavier, but we're going to save time in on draw. So there are lots of caveats on this, there are lots of restrictions, but it's just a simple example. So I wouldn't use this as it is to reduce GPU overdraw, but it serves as a reasonable example. So the first thing we must do is copy the bitmap, because on the next layout pass we want to reuse the original one rather than the one that we're going to screw around with here. So normally we'd save a copy of this somewhere. So we then create a new bitmap which matches those dimensions of the existing one. And we create a new canvas which allows us to draw onto that bitmap. The next operation we do is draw the bitmap onto that new bitmap we've created via the canvas. Again, this is hopefully fairly simple stuff, so I won't go into details here. But this is where we get a little bit cute. The first thing we're going to do is now look at our text view. We're going to detach the background drawable from the text view. So what we do is we call get background to get a handle to it, and we then set background on the view to actually remove it. So now we have this background drawable that isn't connected to anything. We set the bounds on it based on the bounds of the view that it was attached to, which positions it relative to the background image. And we then call draw on the drawable to draw it onto our canvas. So now this background image has an overdraw of 1 because we've just drawn the drawable directly on top of it. And so if we now set this back onto our image view, this entire image view now has an overdraw of 1. It did previously. The text view had an overdraw of 2 in its worst case because it had the background, but now it only has an overdraw of 1. So when it actually on draw actually gets called, the worst case overdraw on there is 2. So we've just flattened things down during the layout pass to save us some time in on draw. So as I say, that's not a brilliant example, but hopefully it demonstrates some of the techniques we'll be using later on to do some more interesting stuff as well. So a second example we'll go into is some background effects. So what we're going to do here, it's very similar again. We've got an image view with a text view on top. For the background of the text view, we want to desaturate the image underlying it. So the layout for this is quite similar to the previous one, image view and a text view. But notice there's no background element to the text view at all. We're just starting with a blank background to that, and we're going to do some tweaking programmatically. So the code again, we start with a bitmap and a view. So rather than passing in the image view again, I'm assuming that we're doing all the backup of that and all the copying that we need to do before it gets passed in here. So there are 2 elements, a bitmap and a view. So we create a new canvas on the bitmap so that we can draw on it. And then we create an overlay. So we're creating a smaller bitmap that represents the dimensions of the background of our text view. So we're just creating a bitmap based on the measured dimensions of the text view. We then create a canvas that we can draw on that overlay, and I hope you can see that, but we then draw a bitmap onto that overlay based on the bounds of where the text view is positioned relative to the image view. Effectively, what that's going to do is a cookie cutter on the image, so we get a copy of the image where the text view would be overlaying that image. I hope that makes sense. And then this is where we do the clever bit. We create a paint object, a color matrix. Color matrix has a really nice set saturation method. Now what set saturation does is remove all the color components from that image. So by setting it to 0, we'll remove all the color elements. Setting it to 1 would keep all the color elements, and you can change it anywhere in between. We then wrap that in a color matrix color filter, set the color filter on the paint object, so 3 or 4 lines of code, and then when we draw that overlay bitmap back onto the canvas, so we're going to flatten it down again like we did in the previous example, the last attribute that we give is this paint object. And so what that paint object does is, as it draws each of the pixels in the overlay bitmap back onto the background bitmap, it's applying that desaturation in the color filter that we've attached to the paint object. So the paint object controls how those pixels are rendered down. So we effectively remove all the color components as we write that back onto the background bitmap. As we're a good citizen, we recycle our overlay because we don't need it anymore because it's now flattened into the background image. And so then when it gets laid out again or drawn again, with the text overlaying that, we've actually created this quite interesting effect where we've just desaturated, which helps the text to stand out from the background image again a little. Now at this point, the 2 examples we've looked at, we've drawn one bitmap on top of another. Now they've been subtly different, because in the last example, all of the pixels in the black and white image that we drew on top completely obscured those in the underlying bitmap, because if we had the color components showing through, it rather defeats the object. So if the red triangle there represents the background image, the blue triangle represents the image that we're drawing on top, you can see there that the blue triangle is completely obscuring that. But that was slightly different to what happened in the first example. In the first example, there was some transparency in the green overlay that we draw in. So what happened was we laid on some transparency, and so you could see the underlying image showing through. Now there are some little rules that help us to do this kind of stuff. And these are 2 words that usually create one of 2 responses in developers. One is, what? The other one is, run away! And those 2 words are porter-duff. Some people will not know about porter-duff rules and will be happy about that fact. Some people will be scared of them. Hopefully some of you will know about them. But one of the reasons that they're quite confusing is because they don't seem very well defined. We like to compartmentalize things and know what they are. And porter-duff rules do a couple of things in one, and I hope I'll try and explain those a little bit. And by dividing them up in that way, maybe they become a little easier to understand. So the first thing, we have the alpha modes. If you look at the 2 images on the left-hand side there, we have our source image and we have our destination image. The checkerboard is a background, it's not part of them, and is used to indicate where there's transparency. So we know that all bitmaps are square, but by having some transparency around the opaque objects, we can make them look irregular shapes. So we have 2 triangles there, even though they're represented in square bitmaps. Now what the porter-duff alpha modes do is control how, when these pixels are rendered using the porter-duff rules that we select, which bits of the transparency will be used from the source and the destination image. Now, the first two portaduff rules that we're going to talk about there are there. They are two of them. There is a rule called source, and there is one called dest. And they will draw just the source image or just the destination image. So not much use, but they're there for completeness. So here's the second. We've got source in and dest in. Now what these draw is the intrinsic area where the two images overlap and where the opacity of the two images overlap. It will output the pixels from those, but either the source pixels or the destination pixels, depending on which of the two modes we use. We then have the complement of that, which is source out and dest out. This is the extrinsic thing. So this is where the two images don't overlap. We output either the source pixels that don't overlap with the dest and vice versa for the dest. We then have source over and dest over. Now, on the previous slide, we saw dest over, and that's effectively what we did when we were overlaying our desaturated image onto the background. We wanted to obscure all of the source pixels with our destination pixels. We then have source atop and source desktop. So what this does is effectively takes the outlines of one of the components, but shows where the other component overlays it. And again, there's the source version and dest version. The final two, clear, again, it just clears everything, so it's not much use. But XOR should be a familiar term to developers. It's going to show the areas effectively where there's no overlaps. So that's the alpha modes. In isolation, I think they're fairly easy to understand, particularly if you just have a play with them and get a feel for how they work. They're quite easy to get your head around. If you sort of throw up some simple examples like this, you can really get a handle for them quite quickly. What makes things a little more complex is there's also some blend modes. Now these kick in when we have some transparency within our components. So in these examples, we're showing opaque components at the top with transparent components at the bottom. So add is just performing a simple addition. Darken, where we have transparent components, looks quite similar, but where we have opaque components is doing something very different. And it's some mathematical rules about how to calculate what the individual pixels are going to do. We have lighten, which when you have two opaque images looks quite similar, but is certainly creating a lighter overlap where we have transparency. Multiply is really out there. That's doing some really crazy stuff. And finally, we have screen. Now, this is the one place where these example images don't show this up very well because it's pretty much the same as lighten. But the trick to these is have a play with them because they are actually very easy to apply. Here's how you apply them. We're using a paint object again. Paint object is really quite cool. I'm sure most of us have used paint to draw something in a particular color, but there's a lot that paint does for us. And in this case, we create a paint object, we then set a transfer mode on it. In this case, we're setting a portaduff transfer mode, and we're specifying which one just with the use of a constant. So all those rules are defined for us. We don't need to do anything other than create a portaduff exfer mode object, assign it to a paint, and then use it in a canvas operation passing in that paint object. And so it's not just bitmaps. You can do it on line drawing and everything. You can apply all this stuff. Now, there are other transfer modes as well. There's a really nice one whose name escapes me as I speak. But what it allows you to do is you can selectively change all occurrences of a particular color in an image. And it's literally as short as that code. Or you can change everything except, or you can affect anything except a particular color. So there's some, if you wanted to do a nice effect where you wanted to desaturate a nice image except all red components, you could do that quite easily, or to leave someone's face in colour, but with desaturating the rest. You could do some really cool stuff with that. So we're going to do some more magic with Paint. Paint, as I say, is a great little API that quite often we don't look at too much. So here's a really nice one. What we're going to do here is we've got, again, text overlaying an image view. And in this case, we've got a desaturated background image, which we're using to draw the letters with. This is going to combine something of the previous technique with something we haven't looked at in Paint yet. Again, it's exactly the same layout. There's no background to the text. We're going to do something as we go. We pass in a bitmap and a view again. We create an overlay bitmap, exactly the same as we did before. We create a canvas. We create a paint object with our desaturate color filter. So this is going to do our cookie cutter again. Now this next stage is where we differ slightly. Previously we copied the color image into our overlay. In this case, we're just going to apply our paint object when we do the cookie cutter bit. So we're going to get out a desaturated image. Now this is where you could do the previous example a bit differently. You could just take this image now, you could create it into a bitmap drawable, and you could set it as the background drawable on your text view. So you don't have to flatten it back to the image behind. You can take this away and just use it in a normal layout. So you can extract a custom background that you apply to your text view. Well, what we're going to do this time instead is we're not going to create a paint object. We're going to get the paint object from our view, which is our text view. And we call then set shader on there. We create a bitmap shader, which is based on our overlay bitmap, our desaturated overlay. Now there's two parameters there, the clamp parameters. What they're for is if the bitmap isn't big enough, it will start tiling it. But as we created a bitmap that's just the right size, because we based it off the dimensions of the text view, it's going to exactly fit the bounds of our text view, so we don't need to worry about that. And so when that gets called, it actually renders those individual characters with that shader that we've just overridden. Now there is a gotcha on this if you're using things like shadows on your text. Shadows use shaders. So if you go in and you splat the shaders like we've just done, it will kill all your shadow effects. But you can combine up shaders. You can. There is a wrapper where you can include multiple shaders together. And if you do that, you just check whether you've got any shaders attached. You combine them up and then you overlay them. And so you can get quite a cool effect, again, just with a few lines of code. And before we move on to the final example here, I'm going to preempt one question that's I think might come up at the end. Is, oh, Mark, you've shown us all these interesting APIs. I bet they're not available until, Honeycomb or KitKat or whatever. Everything we've looked at up until this part was included in API 1. It has always been there. It has been hidden in plain sight and we don't use it. That's a generalization. I'm assuming many of us don't use it. This stuff is there. It is cool. Have a play with it. It's great fun. And so that brings me on to the final thing that we're going to cover, a bit of blurring with RenderScript. Now, again, I hope most of you have heard of RenderScript. In case there's anyone that hasn't, RenderScript is a numeric processing pipeline. It is based on native code. It's generally used for graphic elements and for graphics processing, and that's the primary use, but it's technically just a processing pipeline. It's loosely based on OpenCL, if anyone's familiar with the various graphics languages. It was introduced in API 11, but there is a compat library which brings it backwardly compatible to API 8. So you can still do some of this stuff in 2.x And sometimes you just need some raw processing power. RenderScript will take control, it will introspect the hardware, and it will farm off these operations onto the appropriate GPU or CPU or whatever, and do that for you, and try and do it in the most efficient manner. So what are we going to do? We're going to blur the background like that. Now, I fully accept you can do this in Java, but shit, I'm using RenderScript. Now, you can write your own functions in RenderScript, and you have to do those in a C-like syntax. I'm not going to go that deep because we'd be here all day if I did. So I'm just going to show you there's some built-in functions that are supplied in the Compat library and whatever, and blur is one of them. So we start again. Much as we have with all the examples, it's an image view, a text view. There's nothing, no background applied to the text view, and we're going to do it programmatically. So here's our code. Now, again, this is inefficient, this code. This is deliberately inefficient. If I was to be doing this properly, I wouldn't do it like this, because I'm doing some operations in RenderScript that really we shouldn't be doing in RenderScript, we should be doing in Java. But we've seen examples of them being done in Java, so just for the sake of showing you how to do this stuff in RenderScript, should you need to, I'm going to do it in RenderScript. And hopefully in a couple of slides' time, you'll see the proof of that, so it will ram the point home further. But really, I would do the bare minimum of the bit we need in RenderScript and the rest in Java. And hopefully that will become clear why as we continue. So we've got the same inputs with an additional radius parameter. Now, all the radius is how strong a blur we want to do. It's the radius, how wide a range around the pixels we can apply the blur function. But other than that, we just pass in the bitmap and the view. The first thing we're going to do is our cookie cutter again. We're going to create a bitmap that's based on the size of our text view. Now, you will notice here I've actually added 20 pixels onto the width. The reason I've done this is because of the nature of how blur works. As it blurs these edge pixels, if it ends hard, you get some artifacts appearing because it's hitting the edge of the area. So by giving it a slightly bigger area, you don't get those hard edges which cause these artifacts. And when I paste it back in, I'm going to chop that off again, and so you won't see it. But if I didn't do that, and I'm talking from experience here with the first examples, I was seeing these horrible patterns just at the edges, and just by increasing the size of the bitmap I was blurring, it made it all better and all go away. So we've created our overlay, and it's completely blank at the moment. We then need to create a RenderScript context that we're going to run our RenderScript I will try that again. We then create a RenderScript context that we're going to run our RenderScript operations in. Within that context, we need to make allocations. Allocations is allocating memory. So what we're doing here is we're allocating memory for the background image and our overlay. We're then going to do our cookie cutter operation in RenderScript. So we're doing a copy 2D region. Again, you can see I've added an extra 10 pixels on that to make up for this extra space I added. But again, it's just using the values that we passed in. So we're actually parameterizing these calls into RenderScript from stuff we have available in Java. So we're not fully passing control over. We're setting up all these operations and then executing them. So we've got quite good interaction between the two. So that's then doing our cookie cutter. And this is where we actually do the blur. So script intrinsic blur is a Java API. It's available in the Compat library or API 11 later. It's there. So we create that blur operation. We then set the input region. So this is what it's going to perform the operation upon. So this is our overlay that we've just copied using the copy 2D range. We then set the radius. Now Now, if you're interested, I used a radius of 15 for this effect. And then the for each is what's actually going to perform the blur operation. And that does it on the overlay. The overlay isn't flattened into the background image at this point. It's still floating. It's still a completely separate object. So then we flatten it using a copy 2-day range to go back again. We then need to actually copy our image back from the render script context and into our current bitmap. And that's what the into copy does. We then have to tidy up. So we destroy our render script object. This will implicitly destroy those allocations that we made as well. If we were keeping our render script context alive for longer, we would need to manually free up those allocations if we weren't going to use them. Otherwise, we're going to be leaking memory like there's no tomorrow. But for now, if we just destroy the render script context, that will do it for us. We then can recycle our overlay as we're good citizens. We return it, we overlay the text, and so we get this. So that's all well and good. And I did say that there are some issues. Now this is a timing logger output from that very code that we've just looked at. Now if anyone doesn't know timing logger, again, that's one of these best hidden APIs that no one ever seems to know about. It's a great way of benchmarking code. What it does is, if you're trying to benchmark some code and you repeatedly make logcat calls, logcat is a heavy call because it's doing a load of text processing, it's writing to files, it's doing all sorts. And so you can actually skew your results just by making logcat calls. What timing logger does is you create a timing logger at the start, you call split a number of times on it. Split is a very lightweight function. It just creates a timestamp object within the timing logger object. It doesn't perform any formatting, any output, or anything. So it executes very quick. Timing logger. You get to the end and you call dump to log, and then that goes through, formats all your log output, and writes it to logcat, and you get this nice little report. Now you do have to set a log level manually in your app in order to use it. That's the big gotcha. But there are, if you start look it up, and you'll start seeing some people saying you have to set the log value. Well, what this is showing is that entire operation, that entire code we just looked at, and you can see that the whole thing ran in 72 millis. Now that sounds pretty good, but if you're trying to do animation, that's going to give you at best 12 frames per second if you're doing nothing else, which isn't great frame rates for animations. So you would be looking to optimize that. So this is where you could use timing logger to actually analyze where are the heavy bits. So the blur itself, the blur for each, is 31 millis. Okay, we're doing something. We expect that to maybe be heavy. But creating allocations and copying those allocations out, they're heavy. So every time we transfer data in and out of RenderScript, we're taking a hit. So this is the sort of stuff you need to be aware of, that in terms of raw processing, RenderScript's going to offer us some huge advantages. But if we don't use it correctly, it's going to kill us, because we're going to be doing lots of marshalling in and out of the RenderScript context. So we have to really plan things carefully, isolate where our bottlenecks are that we're trying to reduce, and make sure that we just don't introduce some new ones by doing it. So again, it's worth having a play with these things and understand them and get a feel for, okay, so what happens if I'm doing this operation 5 times, I keep a RenderScript object, a RenderScript context for the entirety of them, I sort of manually deallocate stuff. How does that affect me? Is that going to improve the performance of this? So that's about it for this stuff. But I will just slightly preempt one further question that usually gets asked, and that's about, am I going to release the slides? The simple answer is no. And I hear you saying, Mark, you bastard, why don't you release the slides? The reason I can't release the slides is because there aren't any. The presentation is an Android app. It's running on my Nexus 10 here. All of the slides that you've been looking at, they're Android layouts. All of the animations and transitions are Android animations. And the graphics that you've been looking at within the slides have been rendered in real time using the techniques that we've been discussed. So you can see that there's no noticeable latency in doing some of this stuff. There's no heavy processing going on in the background. And you can see how they render. I wrote a blog series a little while back which covers the presentation software in general. It doesn't cover this particular presentation, but you can see how I do the change from one slide to another and how all the layouts work and stuff. And it is open source. Now the version I'm actually using is a pro version. It's got some extra stuff, like I've got Bluetooth control so I can advance the slides from my phone, and it shows me that I'm vastly overrunning, so I should have no excuse for this. Some of that stuff isn't in there for really two reasons. Firstly, for the live tweeting that's been going on, again, that's because it's an app. I've used a private Twitter API key, so I don't really want to release that, otherwise everyone starts tweeting as me. And also, some of the code really, really is horrible, and I haven't had a chance to tidy it up to release it. But the basic source is there, the slides source is there, all the stuff for rendering these images is there, and I actually just pushed these slides this morning, so it's all there. And anyone that's been following on the Twitter stream should get a link to all of that.
It's not working.
It's not?
No, it's not.
Ah, damn! Ah, well, that's a shame. So, sorry if the Twitter stream didn't work. I guess it's the woes of the Wi-Fi. So, I'll shut up now. Thanks very much for your attention, but if there's any questions, please feel free. I can't believe there's no questions.
We are so amazed.
So I've answered every single question possible on this hour. Well, in case, I'm around for the rest of the day, so if you've got any questions, come and talk to me, or just want to chat, or just want to call me a bastard for the tweets not working or anything, come and abuse me. I'm here for the day, so.
Yeah!
I knew you would. Hi.
What are the ways to deal with the graphics? Run the script, just playing.
Thanks, Daniele.
Just playing Android API and
OpenGL.
OpenGL, and what are others?
There's a few around. If you're interested in games and that stuff, you've got various games frameworks that give you certain graphic elements. So it really is a case of what are you trying to do.
Yeah, sure. I mean, for user interfaces.
Right.
What about OpenGL? You didn't touch that.
Yeah. No, I didn't touch on OpenGL. It was a question of time as much as anything. Plus, I've never really had cause to dive into those. Again, similarly to RenderScript, you do have some hits with making those transitions across to native. So. I think arguably RenderScript is slightly better suited to that because it's built around smaller chunks. OpenGL, you would really hand over a canvas to OpenGL and it would do a lot more processing in a larger chunk. So RenderScript is more for more atomic operations rather than longer lived, but that would be the general rough rule of thumb for what you should be looking at. If you do, basically just want to hand over a canvas and let it do a load of processing itself, go with OpenGL. But if you just want to do stuff like a blur so you want to stuff something in to get a converted image out so that you can use it somewhere else, then maybe look at RenderScript for that.
Is it possible to use The one user example something like X fields. Just for example.
What in render script?
Yeah, that's true.
You would need to convert it into a bitmap within Java and then
Yeah.
pass that in. So you wouldn't be gaining a lot by doing that in render script.
By using caching, I think.
I don't know. I've never tried it, but generally, if you're dealing with views, you want to do them in Java.
In Java. Okay.
If you're really getting performance hits, then you by doing that, then you may be doing some heavy stuff. And so or maybe you need to think, how could I do this better? Are you doing the stuff in Undraw that you could actually move into the layout phase? Because layout phase is much heavier. If you've got a list view, for example, the layouts don't change when you're scrolling a list view. If your Undraw is heavy and you're trying to draw that, Undraw gets called a lot on a list view. So if you've got some heavy stuff going on in Undraw that's giving you a really jaggy list view scroll, then maybe look at moving some of that into your layout phase, because that happens once, and then as you're scrolling, you're just calling Undraw frequently. As long as that layout isn't changing, the elements are all moving relative to each other, the layout's not changing, so you will save some time there.
So I'm logging.
Use Timer Logger. Timer Logger is a really useful tool.
Thanks for
Glad you enjoyed it. Hi.
The library is
So there's probably some issues in the library, I would have thought. It's not. That would be I have seen some issues with shadows. Quite often, if you use shadows and a background to the text, it interferes with them. If you have an opaque background, sometimes the shadow actually is rendered below the background, so you lose the shadow. I've seen that kind of stuff. So shadows aren't great. Their implementation on some nice stuff with them, but there are a few bugs. That's falling foul of the same issues that you could be. So it may be you have to dive into. It's getting it wrong. It could well be what the library's doing is it is doing something with shaders, because you maybe the fill on the text is maybe a gradient or something. So it could be, but they could be doing something with the shader in that which is interfering. They're splatting the shader for the shadow. Now, as I said in the talk, there are ways that you can combine them. Basically, give it two shaders, and it creates a new shader object from them, and it will pass it. And so you can actually build up a shader pipeline by using that. That might be something to try, but it might mean